as we move back into graphing world on page 11 of the notes, today we're going to chat square roots. And here's the good news. A lot of the things we do with square root functions are the same thing that we've already done with absolute value, that we'll be dealing with more with parabolas and lots of other shapes as we move along. So that's always nice. So I know this is going to be shocking. Two ways to go after these. So I'm going to really press the way that I prefer because I think it's easier long term and starts to make better connections than the other, but I'll show you both. So, parent function, okay? F of x is the square root of x. So when we do this, why did I choose those x values? They're perfect squares. We want to keep this easy. Y is just taking the square root of x. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. That's why we like those numbers. We don't want to deal with decimals. Nobody likes dealing with decimals. And so this, again, is what's called your parent function or your base function. We can graph every square root that we do in here based off of this. Okay, so if you can just lock in those values, it's going to make life really, really simple. So when we graph a square root function, it starts at its base and moves to the right. No arrow on the left. Let me mathematically show you why there's no arrow on the left, and then if we think about it for a minute, it'll make some sense on why it is. So if I just put the square root of x, so second and x squared and x in my calculator, okay, am I messing with my graph? Hang on a second here, I gotta fix this. If you ever get funky stuff like this, if you just go to zoom and number 6 Z standard, it'll get back to normal, which, okay, that's better. So notice it does not go any further as far as the left goes. If I pull up my chart, once I get to the left of 0, 0, my first point here, I get error, 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 and it keeps going. Because if you try and take the square root of a negative number, your calculator will give you an error message. We will learn later that you don't have to have it be an error, what's called a complex number. But for now, the error message tells us where our graph needs to stop. It needs to stop anywhere to the left of 0. So the calculator can be helpful if you need a little reminder of that. So once we get that set, though, here we go again with domain and range. Our domain is our x values from left to right. We start at 0 and head forever to the right. And then for range, we're going from the bottom to the top. Oh, gracious. We go at the bottom, start at 0. And again, even though we look at this more as going right, it's also going upward. And we're going up forever. Take note of something. All I'm going to do right now is I'm going to highlight it. I'll talk later on why I am. There is going to be a direct connection as we start to do these between those initial xy values and your domain and your range. If you're looking for little hints to make things go fast, that's going to be it. So kind of keep that in the back of the mind as we start playing with moving these around a little bit. So it's going to be like the longest, look like the longest notes ever, but it won't be as bad as it seems. Okay, so when we start moving these around, okay, we're going to apply the movements, the shifts, the transformations to your parent graph and then plot the new points. This is the easiest way to do it long term. If you're moving left and right, okay, Here is the left and right area. It is going to be the opposite of what you think. Okay, here's why. I didn't put this in here in its actual base format. I should have, so I will now. It's that crazy H and K thing again. But unlike the circles that we just kind of got through a couple of times, we do the opposite of what you would think for H. So you would think left would be minus and right would be plus, but this is the opposite of what it is. That's why they're the opposite of what we see. And then your K on the end is your up and down value, but since it's plus K, it gets to do what you think it would do. Up is plus, down is minus. We'll chat a little more as we get a little further on what's going on with that A value in front, because it does a couple of things too. But for now, that's going to tell us enough. And so in this case, when I look inside, I go, okay, what transformations were done? Well, this would tell me, oops, not that way, Hardy, that I'm going right 1. And this would tell me that I'm going up 2. If you move left or right, that affects the x value. That makes sense. X is on the x-axis. That goes left and right. Every other transformation you do, I shift up, I shift down. I stretch, I reflect, I do all these other things that we're going to talk about with A here shortly. Those all affect Y. Thank you. So, let me color code here. So with this one, when I went right 1, I added 1 to all the x values. Okay, they all went up by 1. And then my up 2 affected my y value, but so did this value in front. Now, there's lots of words that we use for this, okay? I've heard it called compression. I like to just use the word stretch most of the time. We'll get a little more specific sometimes. But whenever you're doing stretches in this up or down, you always do the multiplying first, and any adding or subtracting second. So here, I multiplied the y value by 3. Then we added 2. And that gets you your new 4 points to plot on your graph and go about your business. But there's even going to be a quicker way for that, which we're going to see in this next graph when we start to plot some points. Lot to keep in mind originally, but once we physically do it a couple of times, it's going to make sense. So, this very first one, we're always starting with the parent graph, okay? I would even go so far as to suggest as you're starting here, I'm just going to make dots for my parent graph. I'm not going to connect them. I'm just going to make the 4 dots. It's going to give me a reference point. So here, my one transformation is that 4 in the front for my... So we're going to call this... I'm not just going to call it stretch 4. I'm going to call it a vertical stretch of 4 because it affects y. Y goes up and down vertically. So, when I go to make my new chart, at least for the time being, that stretch means you're multiplying the y values by 4. All of these are being multiplied by 4. This is your actual graph. So I'm going to have 0, 0, 1, 4, 4, 8, and 9. We're going to go a little off here. 9, 12. Here's why I say, especially if you're looking for a quicker way, plot those initial parent points. If you plot them and you know, hey, it's multiplied by 4, you can literally go here and say, okay, so here's 1. 1 times 4 is 4. Hey, here my y value is 2. 2 times 4 is 8. And just move it up. Hey, this was at 3. 3 times 4 is 12. You're off and running. I wouldn't do it right away because I want you to get used to it first. But if you're getting more comfortable, that's going to be an easier way to go. So now, my domain, still starting at 0, and going forever to the right. Because again, we know arrows are infinities. My range, I don't go any lower than 0. But I go up forever. Ooh, what a coincidence. My starting points for my graph are my starting points for my domain and range. That's going to be consistent all the way through. But let's add one more little tiny piece. Do you have a max or a min? Well, it depends on if my point is the bottom or the top of my graph. If my starting point is at the bottom, I have a min. If my starting point is at the top, I have a max, and that starting point is going to be that first coordinate. Every time. There's going to be so many consistent things through this section that once we get a couple of basics down, you're going to be flying through this stuff and going, can we just do this for the rest of the year? And the answer will be, well, no, but it's going to be worth it to see. So now we're going to start flipping things around. We're going to start getting a little goofy here. So let's see here. Starting with my base, and yes, I'm going to keep writing this every time. I want this locked into your brain. So again, we're going to keep it simple for a problem. The only transformation is out here in the front. Now, this time though, it changes a little bit because it's a negative. So, it's going to seem weird that one number can do two things, but it can. So we're still stretching 2, but that negative means my graph is going to flip, and I'm going to show you that in a sec here. So we call that reflecting over the x-axis, and you'll see why we use that wording here in a second. Because what we're about to do, just like we did on the last one, the x values, did I flip those completely around? Nobody tells me these things. Oh no, that's right. Okay. I thought I did something kooky for a minute, and I'm like, can't be doing that already. So we're going to multiply all of our y values by -2. Okay, so the a value always affects y. And so I start to plot those 4 points. And I notice, I'm like, oh. The negative flipped my graph over. Instead of opening above the x-axis, it reflected it over the x-axis. Now it opens below it. That's where that term comes from. And so now I still have got the same starting point. I'm still at 0, 0. So my domain is still 0 to infinity. Left to right, but be careful on range. Well, Hardy, it's still at 0. It is, but that's the top. I'm going down forever at the start of this. So be careful. We're not going to get sloppy when it opens down like this. And because it opens down, this is the top of my graph now. So it's a maximum. But the starting value is still 0, 0. So as long as I can do a couple of shifts around things, I'm not going to get myself into much trouble at all. Now, one last one, then I want to kind of pause for a minute here and kind of see what's going on. Okay, if I need to flip back and forth for a minute, I can. So here, my transformations inside, I'm left 1, and outside, I'm down 3. This is where we're going to get to see everything at play on the graph with shifting and all that other stuff. So whenever we move left and right, we're going to be subtracting 1 from all of our x values. So subtract 1 from each of those. Our y values, if there's an up or a down shift, we're going to do that. So there's no a value this time. There's no multiplying. We're just going to subtract 3 from each of the y's. Those are your 4 points. So here we're at -1, -3, 0, -2, 3, -1, and 8, 0. Okay, so using my chart and making shifts works. Or check this out. If you've got your 4 parent points and you know what your 2 shifts are, you can go left 1 and down 3. Left 1 and down 3. New point. Left 1 and down 3. Left 1 and down 3. And you just shift the points and you're done. So you have multiple options that are good options for this. There's my starting point. So guess what? My domain starts at -1 and goes forever to the right. My range starts at -3 and goes forever up. That's the cool thing about making the chart. You're going to have it right there for you. It's the bottom of my graph. It's a min. But again, it's that same point. The connection's there all the time. If I just allow myself to find it. Okay. Let's play with a little weird. Weird has to happen sometimes. I'm going to go by 4. 4 is a little normal. Normal I'm not worried about. Weird concerns me. So, okay. 3 things this time. Oh boy. What direction's the 3 going? Right. So we're going right 3. We have a vertical stretch of 1/2. We're going to be okay with the fractions. And because it's negative, we're going to reflect about the x-axis. So I'm getting this kind of view in my head of what this looks like. Now this one may be a little trickier to do the shift thing. This is why we have the tables. So I go, okay. So here I'm going to add 3 to all my x values. So we're going to the right. So add 3, add 3, add 3, add 3. Now y. So now what? Well, we're going to multiply by -1/2. for all my y values. So we're going to get some decimally fractionally stuff here. So we got -1/2. Now, as I get rolling with these, so I'm like, all right, I got to quit worrying about some of this other stuff here. So 0, -1/2, -1. -3/2, I'm going to call it -1.5 because, again, we're graphing. I mean, let's be real, that's going to be easier. And so I start to look, and I'm like, okay, so 3, let me change colors. 3, 0. 4, we're at -0.5. 7, we're at -1. And we're a little off the chart here, but that's all right. So my graph kind of skinnied up a little bit, but it's opening below the x-axis. That's the reflect part, and we shift it to the right. Now, here's where I'm going to be quiet for a minute and cross my fingers. What's my domain going to be? Three to infinity. Okay, that rule hasn't changed. What about my range? Nice. -infinity to 0 because I'm going down forever, hence the negative. Max or min? We're at the top of our graph. And there's my value. You see why I like the charts a little bit. This one, if you were going to do the shifting thing, here's the problem, especially if there's a fraction. Because with your points, yes, you're going to go right through, but you're going to do any multiplying first. You'd have to multiply all these by a -1/2 first, then shift them. So, okay, 0, it shifts. That's cool. Multiply by -1/2, go right 3. That gets a little tricky. So, especially if there's an a value, I'd suggest sticking to the chart because it's going to make your life easier. Okay, one last piece, and you've survived all the things. What happens if funky stuff starts going on inside? Like, wait a minute, I mean, okay, right 2, I get that. But what's up, like, if there's a number inside? What the heck is going on here? If the number is inside, it affects the x value instead of the y. That's the only difference. And so now we're going to be stretching horizontally instead of vertically, because x goes side to side, just like the x-axis. So for instance, here, when we did our movements and things like this, let me kind of put my original chart here, which for some reason I forgot to do. So here, what we're going to do is we're going to multiply the x value by 3 and shift to the right. Now, you might be wondering, you're like, wait a minute, Hardy, where's the fractional stuff coming from with this? Because that's kind of tricky. Because what tends to happen is you get into fractions, and sometimes I like to stick with whole numbers. I could put this in my calculator. I haven't talked much about the calculator for good reason, but if you get stuck sometime, it's not a bad option, because here's why. If I pull this chart up, I'm going to be able to see in here where the whole numbers are if I wanted to be able to just graph and then figure the other stuff out. So there's the 1, 1, there's the 2, 2, there's the 6, 4. Like if I'm totally, like brain not working right now, I need some help. This is always an option to go to the calculator and find you some whole numbers. The 2/3 is just me finding my domain and making it a little bit easier on me to do that. You can take what's under the radical, set it equal to 0, and that's going to tell you where your domain would start, because we might need to know that at times. So, if we get into these, and we're just going to play quick with the transformations here. Here, we're going to reflect, because it's negative with the x, about the y-axis instead of the x. So our graph's going to be going this way. So when I do my multiplying, I'm going to be multiplying by -1. I shouldn't put that there. We're going to multiply. I'm going to write it out. So we still have 0, but now instead of 1, 4, and 9, they're all going to be negative. My y's aren't going to change at all. Okay, because they're normally 0, 1, 2, 3 anyway. Did I just do something completely... Oh my gosh, I did. Hardy. 0, 0. Good, Hardy. -1, 1. Where am I going? I don't know. I flipped this completely backwards. You don't see this. This didn't happen. That reflected about the x-axis, not the y-axis. Oh, dear. Oh, Hardy. Hardy, Hardy, Hardy. Reflecting the other way. Instead of going this way, we're going this way. Y-axis. So how does that mess? Does that mess with 0, 0 being my starting point? No. But domain. We're working left to right. Where does my domain start? -infinity. And it ends at 0. And my range from bottom to top starts at 0. And I know it feels weird. You're like, I'm going left though, but I'm going up forever. This is going to be one of those